So today's objective is to solve two-step equations. So I can solve two-step equations. Just know that once again you can pause this video at any point, rewind at any point if I'm going too quickly. So that is what I recommend if I am moving a little bit quickly here. To solve multi-step equations, you are still going to use inverse operations to isolate the variables. In other words, you are going to create a zero pair like we talked about the other day. So inverse operations are for addition, it'd be subtraction, for subtraction, addition, multiplication, division, division, multiplication, right? So those are inverse operations. So example number 1, solving a two-step equations. The height in feet of a tree after x years is 1.5x plus 15. After how many years is the tree 24 feet tall? So here I could say, I could label y, the height, as y, is equal to 1.5x plus 15. And x is the number of years, right? So I'm trying to figure out the height of how many years it's going to take when the tree is 24 feet tall. So because 24 feet tall is given to me in the height, that means 24 is going to be my y. So my new equation is 24 is equal to 1.5x plus 15. So now it's how I would solve a normal equation. Remember, you could draw a line down the middle. The steps I would take is always add or subtract first if you can. There's one exception, I'll talk about that later. So add or subtract first if you can. So for example, here in this problem, I'm going to move this 15 over to both sides first. Then I have 9 is equal to 1.5x. Now I'm going to divide by 1.5, divide by 1.5, and then you are going to get x is equal to 6 years. So you must always add or subtract first, and then multiply and divide is always going to be the order that you go in, except in one case, and we'll talk about that later. Alright, so now I want you to try numbers 1 and 2 on your own. Alright, so for example, here's number 1. You are going to subtract 1 to both sides. You have negative 3z is equal to 6. Divide by negative 3. Divide by negative 3, get z is equal to negative 2. Right, notice how I subtract it first and then divide it, always in that order. Here in this problem right here, I'm going to add first, add the 9 first, add the 9 first. Then I have 1/2 x is equal to negative 16. Remember how I said the other day, if you have a fraction x, a variable, you could get rid of it by multiplying both sides by the reciprocal. So that's exactly what I'm going to do here. Multiply both sides by 2 over 1. Why? Because then these undo each other, and all I'm left with is x is equal to, well, if I multiply straight across, I'm left with x equals negative 32. Okay, next example, here's what I'm given here. Remember, sometimes you'll have to combine your like terms first. Okay, so combine like terms first, and then let's move on and solve. So here my like terms are 8x and negative 6x. If I were to combine those two, you get 2x, copy everything else down, is equal to negative 35. I will add 25 to both sides, add 25 to both sides, right? Because you want x by itself. You're left with 2x is equal to negative 10. Your final step is divide by 2, divide by 2. I got x is equal to negative 5. Here's another example, example number 3. Sometimes you'll have to use a distributive property. So remember, always get rid of parentheses first. So here in this problem, I'm going to use the double rainbows or the distributive property to get rid of that first. Then I'm left with 2 minus 10x plus 4 is equal to negative 8. Let's combine my like terms here. My like terms, it looks like, are 2 and positive 4. If I would combine that, you get 6. 6 minus 10x is equal to negative 8. Be careful here now that you're given this, right? You have negative 10x here, and you're also given positive 6. What do you have to get rid of to get x by itself? You have to get rid of that positive 6. Remember, it's a positive 6, even though you don't see a sign in front of it. So what do you have to do to get rid of it? Right, if it's a positive 6, the inverse is minus 6. minus 6. Be careful with that one. There's a lot of students would tend to add 6 to both sides because they see the subtraction sign that's after. But remember, that subtraction sign is for the 10, not for the 6. Bring everything else down. Negative 10x is equal to negative 14. Divide by negative 10. Divide by negative 10. I got x is equal to 14 over 10. But don't forget to simplify that to be 7 over 5. Okay? Alright, why don't you try these next two on your own. You could check your answer with the people next to you, and then we'll go over it together as well. Alright, so for this problem right here, I'll use the distributive property first. I get negative 3x, negative 3 times a positive 2 is negative 6, plus 5x is equal to negative 9. I'm going to combine my like terms here. My like terms are negative 3 and positive 5x. So that's what? 2x minus 6 is equal to negative 9. Always add or subtract first. I'll add 6 to both sides. And now I get 2x is equal to negative 3. Divide by 2, divide by 2. I get x to be equal to negative 3 over 2. And as I said, fractions are a-okay as answers. And sometimes you'll get them, and that is okay. Number 5, notice how you see parentheses here. If you see parentheses here, remember you always have to use a distributive property. So I have 5 plus, if you 1.5 times 2, that's going to be 3d, minus 1.5 equals 0.5. Let's combine my like terms here. So I have 3.5 plus 3d is equal to 0.5. I'm going to subtract 3.5 to both sides, subtract 3.5 to both sides. So now at 3d is equal to negative 3. Divide by 3, divide by 3. My final answer is d is equal to negative 1. Okay. Last example before we wrap up this lesson. This is the one exception I'm talking about. So use the table to find the number of miles you need to run on Friday so that the mean number of miles run per day is 1.5. Couple things here. You have to understand that mean, if you didn't know, mean means average. And how do you find average? The only way you find average is you have to add up all of the numbers up and divide by how many numbers there are. So now let's figure that out. On the right side, you'll notice all of my data points right here. So now let's add them up. So I have 2 plus 0 plus 1.5 plus 0 plus x. Always include that x too because I'm trying to figure out how many miles I need to run on Friday. Right? So divide by 1, 2, 3, 4, 5 data points. What do I want my average to equal? I want my average to equal 1.5. However, a couple of the steps are still going to remain the same. You still want to combine the like terms first. So if I combine my like terms on top to make this a little bit easier, you have 3.5 plus x all over 5 is equal to 1.5. This is the one scenario where I said you can't add or subtract first, but you have to multiply, divide first. If you're given a super fraction that kind of looks like this, this is what we call a complex fraction. So let's get rid of the complex fraction first. How? By undoing it. Right now it's all divided by 5. So here's what I'm going to do. I'm going to multiply both sides by 5. By multiplying both sides by 5, take a look at what happens. This is just 5 over 1, right? These 5s undo each other. So all I'm left with on that left side of that equal sign, is 3.5 plus x is equal to, if I multiply 5 times 1.5, you get 7.5. Now I'm going to subtract from my last step, and I get x to be 4. So that means I need to run 4 miles if I want my average to be 1.5. Okay? So why don't you circle your level of understanding 1, 2, 3, 4, or 5. And as I said, if I went too quickly, feel free to pause and rewind. That is exactly what a really, really good student would do if you're not understanding a part of this lesson. If not, you could always ask me a question tomorrow. But however, there is a skill check on the next day, and we are moving on to the next lesson. So if you have any questions, feel free to reach out. If not, you could always ask a buddy or two to help as well. Bye, everyone.